No. That's Mr. Kossel.
Excuse me.
Geometry.
Cost Daddy.
Fun Sock Friday, the most flipped day of the week. SBA students will be able to prove triangle similar by angle, angle, side, and side.
Side angle, side.
Section 6.6.
Didn't we do this?
No,
Side.
we had triangle congruence.
Ah.
Yeah, we did triangle similarity.
Yeah. Wow,
So-
this is a big one.
It is, okay? Now, we proved that triangles are congruent in 5 different ways. We proved triangles are congruent in 5 different ways. Throw back to the last chapter, right, Sam?
Throw back.
We did
Throw it back.
side,
Wait,
angle, side,
throw it back.
angle, side, angle, side, angle, angle, side, then hypotenuse, leg.
Can you throw back?
We didn't have like a test.
Throw back. No! I know your advisor has showed you it. Do it. Please.
Do it.
Gracie has
Do it.
definitely showed you it. On TikTok. Throwing it back. On TikTok. He's playing dumb.
No,
They definitely have. Do it.
I don't know what you're talking
Show
about.
it. Somebody show it.
Where's that one?
You. No.
Somebody call him.
Yeah, I know.
Dude, it's so funny when like you don't know
I'm
how
like,
to do it.
I saw you in football when you throw back.
Can you just throw it back? We know you know. We know.
Can you just throw it back? I want a
Okay.
video.
Anyway,
Just throw it back.
side, angle, angle, side, angle, side, hypotenuse, leg. Bless you, bless rain down in Africa, lest
Let
you
me
forget.
forget. Yeah.
Now we are proving triangles to be similar. We're proving triangles to be similar. We can do this in 3 different ways. We can prove triangles similar in 3 different ways. The first that we have is angle, angle similarity. The first that we have is angle, angle similarity. 12:30.
12. Oh my God.
Okay, you want to help slide behind me? So,
Do you want to help throw it back? Just throw it back. Yes, you do. I know you do. We know you know. We know.
He's like
You know
trying
how
to deny it. Yeah, you are. You actually do.
if I did it, if I knew it, I would do it.
No, you wouldn't. No,
Yeah.
yes, you would. Yes, no, you would. Sorry.
Yeah, let's do
You
it.
just go. No, that's not what I did. That is somebody show him on TikTok.
throw it back.
For real.
It would be funny.
teaches that.
I didn't say that.
Yeah, you did.
Really
You
bad.
No, I didn't.
Yeah, you said.
Okay,
I
Okay,
did
we're
not
gonna
say
move on.
that.
We're gonna extend this conversation for now. So, angle, angle similarity. Hey,
I
Mike.
was joking.
Grace, killing the
Yeah.
conversation.
Why would she be
Hey,
serious?
killing the conversation. We're done. Thank you. Okay. Let me do my smile like Julie knows to do. Come on, guys.
Okay.
Go for it. Angle, angle similarity. So, what we're saying here is if we have 2 pairs of corresponding congruent angles, then the triangles have to be similar. If you have 2 pairs of corresponding congruent angles, the triangles have to be similar. You might be asking, hey, Mr. Castle, why is there only 2 pairs? Why don't we need 3 things? Well, it's a great question. Awesome math students. Don't write this down. But
Wait,
Please
who
go,
missed my
fellas.
joke?
Okay. So let's say that we know angle A is congruent to angle D. We know angle B is congruent to angle E. What do we automatically know? If we know those 2 pairs of angles are congruent, what else do we know?
That they are that they have the same boundaries.
Not necessarily. What do we know about the other angles?
Wait, repeat the question.
They have to be congruent. The third angles have to be congruent. If we know both these 2 pairs of angles are congruent, we know the third pair of angles have to be congruent. Okay? So angle similarity says, let's just say for example we know angle A is congruent to angle D. Now I want you to write this part down the line. Let's say we know angle A is congruent to angle D. And then we also know angle B is congruent to angle E. Well then, we'll know that the triangles are going to be similar. So if we know 2 pairs of corresponding congruent angles, now we know the triangles are going to be similar. So kind of like how we went through and did congruence. This is a D. Yes.
You just wanted to roll.
Yes.
Alright, question.
Yeah, 1 second. So I'll answer what kind of error is best in a bit. So for this, you can use any 2 angles, any 2 pairs of angles. We didn't have to choose this pair and this pair. We could have chosen angle A and D and angle C and F, for example. As long as you have 2 pairs of corresponding congruent angles, that's what we care about. Give you any 2 pairs of angles though, Doesn't have to be like the bottom two or something like that. Okay, build up.
I still don't understand this whole side, angle, side, angle, side, angle, side, 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 side. Like, okay, I just need to come up here and like ask a question. Okay.
Okay, he's coming up.
Okay, so there's an angle right.
There's
There's another angle.
Yep.
There's another angle.
Yep.
So I don't understand that.
Make them similar to that other triangle.
So we're saying.
No, but hold on. How does the whole? How do you do the whole angle, side, angle, side, angle, side, whatever? How does that work? Like, 'cause here's a side right here. I don't get it. Does it go like? Does it be like angle and then side and then angle?
So we'll cover that in a second with side angle side similarity. But at first, does this one with just the angle make sense?
Yeah.
Okay, let's stick there for now, and we're gonna get there in a minute. Okay?
Alright.
And I'll have you re-ask the questions.
He's gonna get there.
Thank you, no dog.
Thank you, no more.
So, no, we're not doing the same things as we were doing earlier. It's similar, but we're doing similarity now, so we have some different ones. Okay. So, when we were proving triangles congruent, we had to have everything be congruent to each other. Now, we need the angles to be congruent, corresponding angles to be congruent. Okay, we need y to be off his phone, and then we need corresponding sides to be proportional.
Yeah.
So for side similarity, not only do we have angle similarity, we also have side similarity. So for side similarity, we don't need to know any of the angles, but instead we need to know all three pairs of sides. We know all three pairs of sides. Now for this one, we would need to know all three pairs of sides are proportional. So let's say this triangle is 3, 4, and 5. You don't have to write this down, but let's say it's 3, 4, and 5. And this one is 6, 8, and 10. Well, we could say, okay, if we make it proportionally small or big, 3 over 6 equals, okay, 4 over 8,
Calibration game.
might need to, equals, okay, 5 over 10.
That's really fun.
Now, do these all equal each other?
Yes.
Yeah, what do they all simplify to each other? Does 3 over 6 simplify to 1/2?
Yeah.
Yeah, does 4 over 8 simplify to 1/2?
Yeah.
Okay, and does 5 over 10, 1/2, okay. They all simplify to 1/2. So these sides are all proportional. And we said last section that, hey, that would mean that the triangles are similar. So, if we have side AB, the ratio of side AB to side DE, the corresponding sides on the bottom, is equal to the ratio of, let's go, side AC to DF, the corresponding sides on the left. And that's equal to side BC over side EF, corresponding sides on the right. On that slant there. We're saying if all three ratios are equal, which we have up there, we show that up there, then the triangles are similar. And so my red note is just kind of explaining what this is. So my red note is just saying all the ratios are equal. My red note is just saying that, hey, all those three ratios have to be equal. So here we got them all to be 1/2. And so we have what we call side similarity. We can prove the triangle similar by that. If we know that, that's enough to say the corresponding angles have to be congruent. Just like if we knew angle similarity, if we knew two pairs of corresponding good angles, that's enough to say, hey, the corresponding sides had to be proportional as well. Now, just like we had side angle side similarity, we can have the same thing. Let's say I don't know the length of 5 and 10 anymore. Let's say I just don't know that anymore. Okay? But I still know the other side lengths. I still know 3 and 4 and 6 and 8. Well, we know those two sides are proportional because the ratios are equal. But we said for all three sides we needed, we said for side, we needed all three sets of sides. Here we only have 2. So here we can also do the angle between the two sides. Because it goes, Nolan, this is where your question comes into play. Because it goes side, angle, side, you have to follow along and go side, angle, side. We can't go side, angle, and keep going around on side, because the next thing we see, if we keep going around the figure, is another side over here that we don't know, or another angle over here we don't know. Whereas here, if we go from side, next thing we see is angle, next thing we see is a side of
still don't understand how side works. There's always an
You
angle.
have to
right?
go down, you have to read it down, you have to see where the 4 and, see where this 3 and this 4 is?
Yeah.
So find the 2 sides, and then you have it, you can't go this way because there's nothing marked up here. You can go this way because it's side, then the angle, then the side.
Okay. But how,
You can't go over here because there's nothing marked.
yeah, but how's the side work?
Then it would be side, side, side.
That's just one of them where we don't happen to need any angles.
Oh,
So you kind of like skip over. It's kind of like angle. We don't happen to need any sides, so we're able to
so
kind
you
of
just skip over.
Yeah,
But
but
you
for
gotta
this
read
one,
it.
because it's side angle side,
Okay.
you have to pay close attention to where the angle is. So what we're saying is what you can't do is you can't go side, side, angle, because that's not what this one says. It says side angle side, not side, side, angle, or side, side, angle. Does that make sense?
You have to.
Sure.
Yeah, that makes sense to you? Oh. Okay. Yeah, we need to do the 6.5 similarity too. That would help us, yeah. So here, for side angle side, if we know these angles that are included between the sides are congruent, then that would help us know these sides over here have to be proportional as well, because that flashlight thing, the opposite side trick we did earlier, okay, would help us to know that these aren't necessarily the same length, but these are going to be proportional as well. So because we still know 3/6 is equal to 4/8, because they're both 1/2, same idea. So here, if we know the ratio of AB over DE is equal to the ratio of AC over DF, like we have marked in this picture. And we also know angle A is congruent to angle D. Then we can prove the triangle similar.
Oh my goodness.
So this time,
Wait,
So
can
it's
you all
kind of
just
a-
take it, can you just take a breath? Makes me more relaxed.
We just take Yes.
yo, after at State Wrestling yesterday, so I went for the morning session, the afternoon session. Morning session yesterday was class B and C. Afternoon session was class A and B for the first day, for the first round of quarterfinals.
A&D.
And so,
The last session. A&D.
yeah, what did I say? Oh, Andy. Yeah. Sorry. And so, what my friend and I did, because we had like 2.5 hours between sessions, is at the CHI Center. So we went, walked over to Spaghetti Works, and it's like, cause they had like bottomless like bowls you can get. So it's like $10 for like all you can eat pasta, and like with all these different sauces. Heck yeah, I'm going for it. And so like we just like went ham on it for a while, and like I was like low key just like laid down in the booth and was like, fucking snap. Like I was like I could have went full like food coma.
Yeah.
So
I wish, yeah.
so here what we need. For my little red note for saying what we need in more generally, okay, is we need 2 side ratios to be equal. We need 2 side ratios to be equal. And we need the included angles. We need the included angles to be congruent. So we need the 2 side ratios to be equal and the included angles to be congruent. So it's kind of a hybrid between the first two, and the included angles to be congruent. I think you're asking.
Are we assuming a lot with these 2 triangles? Because when we have our homework, will they be marked better?
Yeah. So like on these triangles, these things I'm marking here, you would have those kind of things marked.
Which I think makes it easier.
What was that?
I think that makes it easier when it's marked.
Yeah.
Okay.
Classic. So note when we prove similarity, the angles have to be congruent. So that was just like with congruent triangles. The angles had to be congruent. But before, some corresponding side lengths had to be congruent as well. Now corresponding side lengths must be proportional. So we're changing that up. So that's what's changing up here from congruent triangles to similar triangles. Angles thought to be congruent, but now side lengths have to be proportional. Whereas with congruent triangles, side lengths have to be congruent because they're the same measure. Questions on that? Okay. Let's go and flip this page. Okay. Oh, what a real G.
I keep forgetting that I'm taking notes and I fall behind because I forget. So I'm just listening to you and I forget.
So, here we have triangle JLK and triangle QMP. Triangle JLK and triangle QMP. And we're trying to say, can we prove these triangles similar? And if so, we want a similarity statement. Okay? Can we prove the triangle similar? If so, we want a similarity statement. So, what was the first thing we did every time we had triangles being congruent?
Marked it.
Mark information, right? So is there any information here we can mark?
57 and 57 are congruent.
Yeah, so angle L and angle M are congruent because they're both 57 degrees.
And J and Q are going to be congruent.
We hope so, but do we have to figure out a measure first? Before we can know J and Q are congruent?
But can't you just tell because it's 75 and
Well, we have to figure out if 75 is going to be okay. Because what if the numbers just don't work? And sometimes these problems are tricky where the numbers just don't work. And they're not similar. But if we prove Q to be 48, or K to be 75, then we would know they're congruent.
We
We know the
already
angles
learned
are
this.
congruent. What?
We already learned this.
Yeah, we're doing it for
So you
similarity.
just, for what?
For similarity now. What? What are we going to do? We're
So
applying
you
the same thing.
add 57 plus 48
Okay.
plus 75,
Okay.
and if that equals 180, then it works.
So we can see if this one is 75, then that would add up to 180. Okay, we can try that. So 57 plus 48 ends up being 105. 105 plus 75 is 180. So this one has to be 75. The other way we did that before
Like
was we took 180. And we took 180 and we subtracted it by 57 and 48. We subtracted by 57 and 48.
For somebody
Thank you.
quiet, I've seen
And you got 75. So now we know this is 75 degrees. So do we know angle K and angle P are congruent too? Yep. So is that enough to prove these triangles similar by one of the three things we just learned? Which one?
yes. Angle.
Angle. Okay, angle similarity is one of them. So we can do a similarity statement just like we did congruent statements before. Can somebody help me with a similarity statement? Triangle this is similar to triangle this.
Triangle LMJ.
LKJ?
Yes. LKJ.
Yep.
Is similar
Mm.
to triangle MPQ.
Very good. By what do we use?
AAA.
Angle similarity. So we actually didn't have the third angle because it's implied, so we actually don't need it. Because it's the two pairs of corresponding congruent angles, then we know the third pair. So it's by angle, and I do want us to write the similarity there, that little squiggle.
But why didn't you do another angle?
Because if we know that the first two pairs of angles are congruent, then we know then it's implied that the third angles have to be
So
congruent.
if I put AAA, that's wrong.
It's not wrong, it's just not even.
You're not going to count it wrong.
No.
And what is this squiggly thing again?
Similarity.
So you have to put that?
Yeah, because we want to make sure we're differentiating between these, saying they're different from our congruents. Even though we don't have an angle similarity, we do have the side congruence and side similarity. So we clarify it saying, hey, this one's a similarity one. Celeste.
Did your arm bruise? When you gave
A little bit. Yeah, I had a little bit of bruising like right up here, but it's gonna move.
Yours is gone.
Did your arm bruise pretty bad? It's still there? Did you have like pain in your arm like when you were doing it? Did you like,
It's huge.
did you have pain? Hey, Celeste. Did you
Oh,
have
they
pain in your
will
arm when
be.
you did it?
Yeah.
So next time, just tell them earlier, like, hey, there's some pain here. I don't think it should be there. And like they'll change it around. Because what happens is like they might have just like stuck it like a little bit wrong, which is like hard to tell unless you like the person's feeling pain. And so what can happen is it's just like some blood can just get slightly outside the vein in your arm, and so it just causes some bruising. So if it's on a much worse scale, then like your whole arm can turn, but it would hurt. But like that's like a very small scale.
Yeah, but if the needle goes in there.
Yeah.
But like,
So like, how do you
but like,
tell if
it
it's
would
that?
still hurt now. Oh, you're saying like, how do you tell if it's that? It's just like a slightly different type of pain than just a normal needle. Like compared to like a shot, it's a slightly different type of pain. But, yeah. So, hey, let's go to the second one. I guess I don't have a number, but this one, we'll call it number 2. So, do we have any information we can mark here? We always like to mark information. We have 2 sides parallel. Okay, we're told side RX and side T, let's cut off there, the TW, are parallel. Okay, what can we do with 2 parallel lines? Marissa?
Well, I know you can do it vertical.
So angle RSX and angle TSW are vertical angles, so there, you're right. Okay. We don't know any side lengths, so we're gonna have to try and do angle. We don't know any side lengths, that's the only one that doesn't involve any sides. Yeah, R and W are going to be congruent. What kind of angles are those that are congruent?
Vertical.
Not vertical would go
Like
alternate interior. Very good, guys. Okay.
Where did you get that from?
So it goes back to chapter 4, where if we have two parallel lines cut by this transversal, they alternate sides of the transversal. One's on the left side, the other one's on the right side of the transversal,
I
And
don't
they're
remember them being triangles.
and they're both interior. Okay. Well, it didn't have to be triangles, so sometimes we just saw this. And so these angles were considered to be congruent because they're alternate interior. It's the same thing, but we just have another line here. That for the purpose of this for a second, you can just kind of ignore it being there. It doesn't change the fact of what's still happening. Does that make any more sense? Okay, great question. Now, could we have also proved, if we didn't remember these were vertical angles, could we have also done the same thing with angles X and T? Yeah, we totally could have, okay? But right now, is this enough to prove these triangles similar? Yeah, by our angle similarity, okay? Can somebody take a stab at trying to do the similarity statement? Somebody other than Grace. Who will use the last one? Okay. Well, I think you're volunteering. Triangle what is similar to triangle what?
R X S.
Okay.
Is similar to W T S.
By what method?
Angle
Angle similarity. So we didn't know any of the sides, which is why we had to go with angle. Yeah. Thank you, Clyde. I appreciate you taking that leap and volunteering, aka just being volunteer, but going with it. Okay. I appreciate that. Any questions on that one? Okay. Let's look to this next one, guys.
Skip the next one and go on to the list.
So, here, how many angles are we told already? We're told some information.
5, 4,
Angles.
2.
Okay, we're told angle NMQ is congruent to angle QMR. We're told that already. Okay, and we kind of see two triangles here, right? The bottom triangle, the top triangle. Okay. And one's obviously bigger than the other, so we're not going to be proving congruent. We're trying to prove them similar. Now, do we have another way we can prove another angle? The last two we've been using angle. So we had two angles. Do we have a way we can prove another angle here? Grace?
Isn't it something like they're on the same? No.
No, we can't. We actually don't have a way to prove another angle. What were we going to ask? I'm curious. You don't want to ask anymore? So we don't have a way we can prove another set of angles. We don't have any vertical angles. We don't have any parallel lines like we did on the last problem. We can't prove any other angles without any other information that we're told. So what we can do is we have to look at sides. Okay? We don't know all three sets of sides because we're missing NQ or NP, and RQ. So we can try and do side, angle, side. Two sides and their included angle. Do we know the length of this side? 4. Okay, so we can try and set up proportions. Just like we did before, we can try and set up proportions and see if they're going to be similar. So we did small over big before. So we can do 4 over what? 6. 4 over 6. 4 over the small triangle over 6 of the big triangle. And we can see if that is equal, and that does simplify to 2/3. We can see if that is equal to, what's this side of the small triangle? 8. Now what's the side of this big triangle? 12. How'd you get 12, Wyatt? 8 plus 4 is 12. Okay? So now we can say, are these two sides proportional? And if they are, then this would be enough because we have two pairs of sides and the included angles. Okay, the angles that are between them. So 4 over 6, like Grace said earlier, does simplify to 2 over 3. 2 goes into both. What goes into both 8 and 12? 4, and it becomes 2 over 3.
3.
Jeepers.
That was easy.
And done.
So these are similar because we can we have two pairs of corresponding congruent sides. Not corresponding congruent sides, excuse me, corresponding proportional sides. It's supposed to be 2 over 3. You got like massacred by my pen. Okay.
So
I'm
we're
blaming
not
the board
saying
again.
that.
Don't worry.
So we're not saying that the two triangles are congruent. We're just saying that they're similar.
Yes. Yep. Because they're obviously not congruent because this side is 6 and this side is 4.
Oh, okay.
But if this like we took this triangle and we just like stretched it all out the same by the scale factor from before.
Okay, that makes sense.
It's kind of like when like a model set, like a car or like a train, like a model set is like a lot smaller than normal, right? But it's not like the tires on the model car are like normal size, then the rest of the car shrunk. You shrink everything at the same kind of thing. We shrink all the sides together the same, so they're still similar. So if you just expanded it, you get your normal car, your normal train. So what we can do for our similarity statement here is triangle something 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 is similar to triangle something something something. And I get a volunteer for this one to try and do this similarity statement.
Can I do it?
Okay, you can do it.
Okay. Triangle MNP
Okay.
is similar to triangle NRQ.
Very good. That would be definitely one way we can do it. So triangle MNP is similar to triangle MRQ. And what would this one be by? Does anyone know?
Angle, side, side.
We don't have one of those.
Angle, angle, side.
Don't have one of those. Side, angle, side. Because if we look at the order we have, we went from side to the angle to the side. We went from side to the angle to the side if we just keep going around the triangle. Because if we go this way, we're skipping over stuff. We're skipping over a whole other side. So we're going to go side to this angle to this side, or this side to this angle to this side. And we don't like side angle because that's a bad word anyway. If you just flip it around. So if you flip it around, it's a bad word. We don't like bad words. Okay.
I
We're on
do.
a Christian Minecraft server.
I love bad words.
Ooh.
I feel like you're the type of guy that's never said a bad word before.
Not true.
He definitely has.
That goes on. So on the
He
fourth
like
one here.
thinks it's a sin.
We're not gonna get into theological opinions in here. Super not supposed to. So we won't.
My back is feeling perfect.
What? We talk. Okay.
What?
So,
No, that was
I know.
cool.
I know. Oh, I was like,
Good talk,
not
Colton.
everything's about you, Jillian.
Yeah.
I didn't
So,
see that. I
Colton,
thought you
sit
were
back
talking
down.
to me.
I can't.
Why not?
That's spinal cord issues.
Okay, go walk around with your notes.
He comes over here to bother me.
Yes. Okay, on this next one. What do we know about these triangles? Triangles are congruent. What do we know about these triangles right now? What's marked? Okay. We know angle 57, angle 61. We know these two sides are congruent. We know these two sides are congruent. Do we know anything about this side to this side? Okay. Yes.
I have a question.
Give me some
So-
of that protein, boy.
What kind of triangle is this one? Then we know if we just isosceles. How do we know it's isosceles?
Because two sides are
Two
congruent.
sides congruent. Now what else do we know is true about isosceles
The
triangles?
bases are the same.
The base angles are the same. So this angle is 61 degrees, so this angle must be 61 degrees, right? So could we figure out this angle up here?
Yeah.
By doing 180 minus 61 and 61. What is 61 plus 61?
122.
So if we take 180 minus this 122 jeepers creepers. Okay, then we can figure out this angle ends up being
293. No reply.
No, we're. Why would we try?
Okay, well his thing looks like an @ sign, so I don't want to keep it.
ends up being 58. So this ends up being 58 degrees.
58.
Now do these even look like they're going to be some? Are the angles congruent then?
No.
No. Okay, we also could have found these angles because these angles have to be congruent to each other, and so we could have found those angles to be 61.5.
You did that way harder than it could have been.
I don't think so.
Well, guess what I do, sir?
So are these triangles congruent or similar then? Excuse me. No, they're not similar. So
No.
we can say
No.
not similar.
Does this say
Okay.
61.5?
Yes. And our reason for this can be corresponding angles are congruent. You can say this angle is not congruent to this angle. You can say 57 is not equal to 58. There's all sorts of explanations we can do just like before. There's all sorts of explanations we can do. Okay. Question on that one? Woo! Okay.
Bam!
Alright, Lois. Okay. Is triangle KML similar to triangle QSR?
No.
And is triangle NPO similar to triangle QSR? Well, I just have this third one covered for a moment, just so we can focus on the first two triangles, because that's the first question it's asking. Then it goes through and asks the second question. You'll only go pick it up and then do 10 push-ups for missing.
What?
Oh.
So, if you can.
If I can.
Yeah, if you can, do 10 push-ups.
You can't.
10
I have a gimp shoulder
Yeah.
You
dog.
have to do 10,
Oh, for crying out loud, I can do 37 of them.
Ooh, Miss
Wait till the end
Haslow.
of class.
Get it,
No.
girl.
Yeah.
No.
You're interrupting the lesson. We're trying
No,
to
it's
learn
okay.
here,
You
dog.
interrupt unless
Nope.
I'm throwing something.
You got it, go.
You interrupt.
I didn't interrupt
You
anything.
sound like Mr. Titus.
Go ahead.
Oh my gosh.
10
Thought I was.
in the front of the class.
Yeah, in the front of the class.
class.
You can go
doesn't
there.
matter.
You can go there.
1, 2, get lower.
4,
That was loud, I'm sorry.
6, 7, 8,
Hey, you don't do that.
9, 10. There we go. Thank you.
Get loud.
Okay.
I judge.
And I'm not even going to call you baby. 'Cause that's
Teachers
weird.
these days.
Okay. I know. Some of them.
Trying to get you to exercise.
So we're going to look at the ratios of corresponding sides. So before we had done a couple angles, we had done a side angle side. Now we're going to try some side. So we're going to compare. You guys remember how we did the small over big before?
No.
Small over
Yes.
big
I'm
triangles.
kidding. Yeah,
Now we're
I
gonna
remember
do-
that time.
We're going to do the same kind of thing. We're going to do the short sides together, the medium sides together, and the long sides together. So we're going to compare the short sides together, the medium sides together, and the long sides together. So regardless of what order we think these triangles are going to go, we're going to try lining them up. So what do we think our small triangles our small sides are going to be? Excuse me. Gracie said a moment ago.
6 and 10.
Yeah, so we're going to try 6 over 10. Look at the ratio of corresponding sides. So we start with the small triangle 6, big triangle 10, with the small sides.
And then
And then we do the medium
15
sides.
over 25.
Okay, 15 over 25. And now let's do the long sides.
18 over
18 over 30. Now what we're trying to do is we're trying to say, are these ratios equal? So we can simplify each of these. Okay? Or another way you can do it if you don't want to simplify, guys, or if you're finding out that you're having trouble simplifying, is you can type into a calculator 6 divided by 10, because the fraction's a division problem. Okay? And if you get the same decimal for each of these, that's the same thing. But what goes into both 6 and 10?
2.
2, and it becomes 3 over
5.
What goes both into 15 and 25? 5. It becomes
3.
3 over 5. Okay, so far so good. The last ones work. They're similar by side. What goes
9.
into both
Six.
18 and 30?
Nine.
6. goes into 18 3 times, 6 goes into 30 5 times. So are they all 3 over 5? Yeah. Is that 6? 5 messed up. So are these triangles similar?
Yes.
Yes, the triangles are similar by side, side, side. So we can say triangle KML is similar to triangle QSR. Similarity statement's already given there. By side, 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 similarity.
I love when we're doing like the little like swirly thing. So I'm like really good at it.
Oh, nice.
Yeah, like look at that. That looks like you typed that swirly thingy.
Yeah,
I like really good. That means you pass my singing.
Hey, that is actually really good.
I know.
Yeah, that is actually a super good.
Ben said.
So now, guys, I want us to try and do the same thing with NPO, triangle NPO, and triangle QSR. So this third triangle and the second triangle, and try and compare them the same way. Okay? So we're going to go the same way through this. We're going to go through short sides, medium sides, long sides. Now, this won't be written for you in the future. The short, medium, long, that won't be written for you in the future, but you can still do that on your own. Okay? It's just teaching you a method to go through it. Okay? So I want us to go ahead and try this one.
But we don't have the
Okay.
smaller
We don't need the angle.
Okay, so not the bigger triangle.
Yeah, we're just doing these two right now. NPO and QSR. So now we answered the first question. Now we're answering the second question. Is triangle NPO similar to triangle QSR?
Okay.
So we can go through the same process we did on the left, but over here on the right with these two triangles
Okay,
instead.
gotcha.
And we're trying to say, are these triangles similar or not?
I'm so tired.
I'm so tired of Mr. Parsons.
No.
I'm so tired.
Everybody has to do it.
I'm so tired.
I'm so tired.
This is gross grammar.
I'm so tired.
Oh, I didn't know you wanted to.
Oh yeah, I mean that's pretty confusing when I asked you to.
There's only one triangle. How do you do that? The second triangle.
Okay, what's the question asked? What's the second question asked?
Can you like to the side? Your side look over.
Of those two triangles.
NPO.
I'm not like
You-
staring at you, but like when I just like look over, your like eyes just like
So far so good.
I was thinking. Oh, are we supposed to be on this one?
I don't know.
NPO?
We can put the color of my socks matching, which they aren't.
How do you wear those? Like the shortcut socks? That would drive me crazy.
I can't wear long socks. If it's touching my
Nothing goes in.
touching my knees.
I don't mean like touching your knees, just like, nobody wears that. It's hard to show.
Socks that touch
Oh, I don't like socks that high.
Not that high?
The problem is they roll. You know, like when they roll, because it's like all cramped.
So you don't stretch them out.
Those socks are gross, bro. I don't wear socks.
Don't you ever just want to hit something?
Yeah.
Especially if you have hairy ankles.
Of course you do.
I didn't say no, I said oh.
Kids, you literally
Oh,
have blonde
so
hair.
you do. You're gonna be, I thought you were gonna be like, no, I would never.
And you're blind.
Well, she's like,
You can see it.
From right here, I can barely tell
Look
you
at my
guys.
ankle. It's intense, man.
Hey. Newsflash, look. You can see that hair. Yeah.
Look at my ankle, bro.
newsflash.
What's their medium size?
I asked you to check your miss for off the screen. You told me you wouldn't.
Yeah, I would have known it did that.
Yeah. So which one would you fill out? Yep. 5. Oh.
That never happened.
Uh-huh.
She's so
I didn't-
confused.
I did it.
Here we were able to see all those.
I might listen
No, I
to
didn't.
Oh.
No, I didn't.
I said you did.
I'm so confused.
Yeah, I saw it. So what
I'm so
did you stare at
tired.
it? No,
I'm so tired. My name is
Ew.
Okay, let's talk about this one up here.
Ah!
So the short sides. Where's the said those are 3 over 10?
And then 5
The medium size, okay, 5 over 25. and 7 over 30 for our long sides. Now the only one of these that we can simplify is the middle. The only one we can simplify is the middle. 5 over 25 ends up becoming 1 over 5. Are these ratios equal?
Yes,
No. So the triangles are not similar.
Not.
The triangles are not similar, okay?
That's what I thought.
Okay, these ratios are not equal. The triangles are not similar. And the explanation you can have is just saying, hey, 3 over 10 doesn't equal 1 over 5. That could be a good explanation. 3 over 10 doesn't equal 1 over 5. Okay. Questions on that?
Yes, we are.
Yeah, we can be done.
Let's go. Best teacher ever.
Oh, thanks. Remember this next week when you don't like me, okay?
What?
I don't know. I'm sure there's going to be a time when you don't like me next week. Jillian's laughing because she knows it's true.
I passed every quiz and every test ever created.
We both end up yelling at
You
Right, 5. Try it one more time. Let me see.
I just don't like
There's a mistake.
Maybe I did.
Watch our basketball team lose today.
Well, they do. You guys are bad.
1-14.
Wait, who was that?
Gross.
Gross are 1-14.
Oh.
They just beat Nev City and we barely beat Nev City.
Yeah.
Wow, that just shows how good you are.
JV might take that fat dub though.
Our freshman team almost beat them.
Cool, why don't you play basketball?
Because he won't let me.
Why?
He's mean.
I know, totally. It should
It should
Play
definitely
next
like
year.
It should
Because
definitely.
I'm playing
Okay.
rugby.
Jill.
Hey, do you guys want a couple don't do's?
Yes.
Cool.
Please. Thank you.
7
I am done.
Hey, Colton, you have to do all of them, but the rest of the class, you don't have to do.
You're funny.
But I need.
And thanks, I like to think so. Don't do numbers 10 and 12.
There's no 10 and 12.
What? Did I get it wrong? My goodness, what am I looking at?
You're a bot.
Sorry, don't do 4, 5, and 9.
Yes.
I bet.
4,
4,
5, and 9.
5,
One more.
9.
So we have to do 10 and 12?
It's
Yes.
one more.
Can I add my own 10 and 12?
Why won't he let you do it though? What did he say?
I'm too big.
Austin?
I'm
Yeah.
faster than Austin. too.
Austin?
Okay,
Austin
well,
can be fast
Fulton shouldn't
sometimes.
be saying that, and if she does, then you just go record.